This presentation is over different mounting medias used to mount hair samples for microscopic analysis. For forensic investigation, hair is a commonly seen piece of evidence at every crime scene. This is due to the abundance of hair all over the body and the fact that it's easily shed and transferred from one surface to another. By observing the evidentiary hair samples, trace analysts can determine different characteristics of the hairs. For example, the analyst can determine from what area of the body the hair sample came from, whether it came from the head, pubic area, or the arms and legs. The analyst can also observe racial characteristics of different hair samples. Racial characteristics can be viewed under macroscopic detail or through the cross-section of the hair. In addition to human hairs, animal hairs can be frequently collected at a crime scene. It is therefore very important for forensic investigations that a trace analyst be able to differentiate between animal and human hair. Hair is typically observed under both the stereo and compound microscopes. A stereo microscope allows observation of macroscopic characteristics. These include the color, form, diameter, and length of the hair. On the other hand, a compound microscope allows microscopic observations of the hair. These include the reflected color, microscopic structure, and cross-sectional shape. To view these samples under the compound microscope, the analyst must mount the hairs on a slide using a cover slip. There are many different types of mounting techniques used for hair samples. The most common are dry mounts, scale casts, melt mounts, and the cross-sectional mounts. The type of mounting media used is dependent on which mounting technique you are utilizing. The dry cast does not require any mounting media. You simply place the hair sample with the cover slip on a glass slide. The scale cast requires nail polish or a Polaroid film coating as the mounting media. The analyst will first place the mounting media on the slide. He will then place the hair into the mounting media and let the media dry. After the media is fully dried, the analyst will remove the hair from that slide. This type of mounting allows for a visualization of the scale patterns located on the outside of the hairs or the hair shaft. For the melt mount, the analyst has a number of mounting media to choose from. These include water, per-mount, argan oil, Canadian balsam, melt mount, and many others. The different mounting medias allow for permanent or semi-permanent hair slides to be created. To create a slide using per-mount, the analyst needs the per-mount mounting media, a glass slide, and a cover slip. After placing the sample on the slide, the analyst will add 1 or 2 drops of the per-mount to that slide. Then the analyst will slowly lower the cover slip at a 45-degree angle to the slide until it is placed. This helps prevent air bubbles from forming underneath the cover slip. After laying the cover slip, the slide is now ready for view under the compound microscope. Conversely, the melt mount is generally used as a semi-permanent media, although it can be a permanent one as well. When it is applied at room temperature, it is a solid. However, when exposed to heat, it forms a liquid. Therefore, the slide must be prepared with a heat source so that the melt mount is in a liquid form. Once the heat source is taken away, the melt mount solidifies on the slide with the sample embedded in it, thereby making it permanent. However, if heat is applied again, the melt mount will liquefy and allow for manipulation of the sample, thus making the semi-permanent melt mount. The last type of hair mounts that I will discuss is used to observe the cross-section of the hair. This section is often observed to differentiate different races. There are 3 different types of mounting to observe cross-sections. There is cross-sectioning by embedding the sample, which is the one I will be describing, cross-sectioning by sandwiching the sample, and cross-sectioning by using a microtone. For cross-sectioning by embedding the sample, the analyst first fills a pipette tip with the hair sample. The analyst then melts the tip of the pipette on a hot plate so that the tip of the pipette is flat, thus embedding the sample. Then the analyst will cut a very thin cross-section of the hair by placing a scalpel or razor perpendicular to the sample and cutting. The cross-section is then mounted and observed under the compound microscope.